So next is residue integration. In the fifth module, next topic is residue integration. So first of all, what are singularities? Singularity is a point at which the function f of z is not analytic. That is, if a point z0 is called a singular point if the function f of z is not analytic at z0. So f of z is a singular point if it is not analytic at that point. Analytic allatha point and singular point. For example, f of z is z square plus 1 by z minus 1, z minus 2. Z square plus 1 by z minus 2. So from this, the denominator is z minus 2, and if you put z minus 2 as 0, we get z is equal to 2. So at z is equal to 2, the function f of z is not analytic. Or we can say that z is equal to 2 is a singular point. Okay. Then types of singularities. So there are 4 types of singularities: isolated singularity, removable singularity, essential singularity, and pole. What is essential singularity? Isolated singularity. What is called an isolated singularity? First of all, we will see what is an isolated singularity. So a point z0 is called an isolated singularity if f of z is not analytic at z is equal to z0. That is the definition of singularity itself. So if the function is not analytic at z is equal to z0, that's the first condition. And second one, there exists a neighborhood of z is equal to z0 which contains no singularity of f of z except z0. That means z is equal to z0, the neighborhood of z is equal to z0 contains no singularity other than this is z0. Okay. So it is like isolated singularity is the normal type of singularity. Then second one, for example, z plus 1 by z into z plus 2. So for this function, denominator is z into z plus 2. So if you put z into z plus 2 as 0, we get z 0 and z plus 2 as 0. So z is equal to 2 and z plus 1 by z into z plus 2. So z into z plus 2 0 means either z is 0 or z is minus 2. So these are the singularities. Okay. So these are the isolated singularity. Next one, removable singularity. A point z0 is called a removable singularity if z0 is an isolated singularity and if the principal part of f of z at z is equal to z0 has no terms. So that is the removable singularity. What is the principal part of f of z? That is the terms of z minus z0 which are lying in the denominator in the Lorentz series expansion. Okay. So a point z0 is called a removable singularity if it is an isolated singularity and also there are no terms in the denominator. No terms of z minus z0 in the denominator. For example, sin z by z. Sin z by z. So if you expand sin z, it is z minus z cube by 3 factorial plus z raised to 5 by 5 factorial etc. divided by z. And if you divide each term by z, we get 1 minus z square by 3 factorial plus z raised to 4 by 5 factorial minus etc. So we can easily see that all the terms of z are in the denominator. No terms of z are lying in the denominator. All the terms of z are in the numerator. Okay. All the terms of z are in the numerator. No terms are lying in the denominator. So, but if you look at this sin z by z, we will feel that denominator is equal to 0. That z is equal to 0 is a singularity. So it is correct. It is a singular point. Z is equal to 0 is a singularity. But what type of singularity is that? It is a removable singularity. That can be obtained by looking at the expansion. Okay. So that is removable singularity. There is no term in the principal part of the Lorentz series expansion of f of z. Okay. So that is removable singularity. Next one, essential singularity. What is an essential singularity? Z0 is an isolated singularity. So first of all, Z0 is an isolated singularity, and that singularity is called essential if the principal part of f of Z has infinite number of terms. That means there are infinite number of terms in the denominator in terms of Z minus Z0. For example, e raised to 1 by Z, it is 1 plus 1 by Z by e raised to x is 1 plus x by 1 factorial plus etc. So it is 1 plus 1 by Z by 1 factorial plus 1 by Z the whole square by 2 factorial plus etc. So there is a term fraction or denominator in the numerator. Okay, so that Z goes to the denominator. So it is 1 by Z factorial, 1 by Z into 1 factorial, then 1 by Z square into 2 factorial, etc. So all the terms of Z are lying in the denominator. That means denominator means it is the principal part. So there are infinite number, etc., etc., up to infinity. So there are infinite number of terms in the denominator. So we can say that, which is the point? Put the denominator as 0. So Z is equal to 0. So Z0 is a essential singularity. Next one, e raised to 1 by Z minus 1 by Z. So similarly, we can expand this 1 by Z by 1 factorial plus 1 by Z square by 2 factorial, etc. minus 1. So 1 minus 1 cancels, whole divided by Z. So we get 1 by 1 factorial plus 1 by Z square Z into 2 factorial plus etc. Okay, so here also we can see that all the terms of Z are in the denominator, and it goes to up to infinity. So Z is equal to 0 is an essential singularity. Then what is a pole? Pole is also a type of singularity. So first of all, Z0 is isolated singularity. Then it is called a pole if the principal part of Z has finite number of terms. That means e raised to Z by Z. So expanding, whole divided by Z, we get 1 by Z, then Z by Z cancels, so 1 by 1 factorial, Z by 2 factorial plus etc. So up to infinite terms, all the terms of Z are in the numerator, infinite number of terms in the numerator. So that does not bother us. So how many terms are in the denominator? That is a principal part of Z. So only one term in the denominator, 1 by Z only. Okay. So Z is equal to 0 is a singularity, which is called a pole. Okay. So if there are a limited number of terms in the denominator of in the expansion, then it is called a pole.